Chapter 5, Section 7, this is dealing with scatter plots and trend lines. So our objectives are to write an equation of a trend line and of a line of best fit, and then use that trend line and line of best fit to make predictions. So here's what I'd like you to write down for a scatter plot. Sorry, I had some writing on there already. I want you to write down this section, so pause the video and go ahead. So what this is saying is a scatter plot is just a graph that relates two different sets of data. So we're talking about two different measurements. And we display that just using points. So each one of these points is somebody's answer. So it's a certain answer for X and a certain answer for Y. We usually do those in the first quadrant. So if you remember, if we were to draw, if we were to go ahead and draw the, like on a piece of graph paper, this right here would be the first quadrant up here. And we usually use that because most of the data that we use is always positive. If it's not positive, then we have to use something else. But the majority of the time it is. So that's why you only have to draw this little L-shaped, which is the first quadrant. Correlation. Correlation is just a measurement, which we're not actually going to find the measurement. You do that in probability and statistics if you take that class. But correlation is how much one thing has an effect on another, or how much one thing is related to another. So it's not always that X has an effect on Y. It could be that X just seems to happen at the same time as Y. And what we mean by happening is, like on a positive correlation, as X gets bigger, so does Y. So as you go further to the right on X, your Y's also get bigger. Negative correlation is when you go to the right on X, meaning get bigger, your Y's tend to get smaller. And no correlation is when the data is just all over the place and there's no really rhyme or reason to it. Let's see if I can erase this. Okay. So here's what we're looking. We're going to use this and make a scatter plot. So we're going to use this data here, and we are going to make a scatter plot for it. So we're just going to quick make first quadrant. Down here is going to be my altitude, and up here is going to be my temp. And I'm going to do it real quick. So 0, 59, we'll say we're going by about 10s, 10, 20, 30, 40, 50. So 0, 59 is, oops, 60, sorry, would be up here. Right about there. And we'll go by about 500s down here. So 559 is right about there. 1061 is a little higher. 55 is right about there. 2041 is right about there. 2529 is right about there. 3029 is there. 35 and 18, we're looking right about there. 4026 is up here. 45 and 12 is down here, and 5000.6. So you see what you're looking at? As the data gets bigger, your Y, as the altitude gets bigger, your temperature goes down. And so that's what we call a negative correlation. Now, why do we have our scatter plots? Don't worry about this stuff right here. Our scatter plots will then give us a trend line, and the trend line is also sometimes referred to as a line of best fit. And what we use that line of best fit for is to make predictions. So you notice how the trend line does the best it can at following the data. Now understand that your trend line or your line of best fit and somebody else, their line of best fit may not always be exactly the same. Sometimes people go for trying to hit the most points. Sometimes people try to hit like the same amount of dots on the top and on the bottom of the line. But what's wrong about that is if you were to just draw a line straight across, you could say, hey, I got 1, 2, 3, 4, 5 above there, 1, 2, 3, 4, 5 below there. There's my line of best fit. And we know that's not the case. And so there's not really always a rhyme or reason when you're doing it by hand. There is a mathematical calculation that you can do to get that, but we're not going to go about that. So here's what we want to do. Make a scatter plot for how old a panda is and how much it weighs. And so these are going to go up by tens. Okay? So this is going to be 1 month old is about 2.5 pounds. 2 months old is 7.6. 3 months old is 12.5. 4 months old is 17. Then it hops over to 6, which is 24, which is about there. Hops over to 8, which is 37, which is about here. 10 is 49. 1, 2, 3, 4. 49 is about up here. And 12 is about 54. And so now what we want to do is get a line of best fit for that. And so if I were to draw a line, I would probably draw something right about there. Okay? And now what we're doing is, so now we have that line of best fit. And now if we want to write an equation for it, we need 2 points. So what we're looking for is 2 points on exactly where it lies. And I would say for me, there's one right there. So that's at 2 months and 10. So that's 2, 10. And I would say I also am pretty darn close right up here. So that would be 13. And what was this? 1, 2, 3, 4, 5, 6. 13 and 60. And now I can take those two and I can find my slope. So I'm taking my y2, which is 60 minus 10, my y1, and my y2, which is 13 minus 2. So I got 50 over 11. So that's my slope, 50 elevenths. And then I can plug that in and to my slope-intercept form, or I'm sorry, my point slope, and I can get an equation. So I'm going to take y minus 10 equals 50 elevenths times x minus 2. Y minus 10 equals 50 elevenths times x minus 100 over 11. And if I add 10, which 10 would be 100 tenths, if we change that to elevenths, we would have to be 110. So I'm going to add 10, and when I add 10 over here, that's actually 110 elevenths. So what we end up with is an equation of y equals 50 elevenths x plus 10 elevenths, so almost 1. And that is now my equation. And if we asked, okay, what's the approximate weight of a 7-month-old panda? I could just plug in 7 for x. So now I get y equals 50 times 11 times 7. Sorry, 50 over 11 times 7 plus 10 elevenths. So that is, 350, elevenths plus 10 elevenths, which comes out to be 360 over 11. And 360 over 11 is about 32.7. And if you look at my graph, 1, 2, 3, 4, 5, 6, 7, go up, that's right there, which is approximately 32.7. If I go across, that's approximately 32. So that's what this is used for, that trend line. We can just get an equation, and now we can make predictions, such as how much will a 2-year-old panda, one that's 24 months, how much will one of those weigh? And eventually, you know, this line has to kind of flatten out, but that's what we use this for, and that's what this section is all about.